So what is a Boltzmann machine then? So Boltzmann machine is foremost is it is a part of an unsupervised learning. In unsupervised learning, you provide some input to a machine or to a model and let it decide the features it has and to find the interrelationship between your data. You don't provide it with the outputs. You let machine to figure out what are the relations or features that are binding your input data. So in a simple or standard term, a Boltzmann machine is a network of symmetrically connected neuron-like units. Some may say it as a feature, some may say it as a nodes that make a stochastic decision about whether to be on or off. This we will understand in our next video when we try to move on to a practical section. Boltzmann machine are undirected models. There is a no direction. That means connection goes both the ways. So data goes from A to B and from B to A. It is a non-deterministic model because you don't have an output in this. Its most purpose is to optimize the solution, and the common thing you will find is that optimizing a traveling salesman problem using a Boltzmann machines. It discovers the features from your data sets composed of a binary vectors. So how Boltzmann machine looks. This is a standard diagram for a fully connected Boltzmann machine. These are three. For the sake of understanding, we have divided, or it is divided into two colors, red and blue. So blue are the nothing but they are the visible layers. Visible layers are the layers that are known as also input layers. So these are our input 1, input 2, input 3, and then we have our hidden layers which are not visible, or you can say these are the neurons. The first thing you can notice is that everything is connected. Every node or every neuron is connected with each other. Even the inputs are connected with each other. Second thing you will notice, there is no kind of an output layer. Normally we have input, we have hidden layers, and we have an output. And these are layers is also seems to be bit in different format. It is not kind of a standard we have seen it in a horizontal line or a vertical line. This has some kind of a thing, seems bit different. So what this shows, so you have an inputs and your Boltzmann machine will try to find the relationship between this particular inputs using these particular features. And these features are created by machines when it start learning from your input data. It has no output data, it just want to correlate your data. On basis of the data that you have provided, it will try to find out some kind of a relations. And it may name it as a feature A, feature B, feature C, which is at all not understandable by human being, but machine can understand. So once you have trained your Boltzmann machine, then you can use it to recommend something. So mostly they are used in a recommending systems. So now what is the problem with a fully connected Boltzmann machine is that there are too many interconnections, and processing and tracking all that is difficult to achieve. Although in theoretical it seems very simple. So we have a second type, that is a restricted Boltzmann machine. So in restricted Boltzmann machine, you can see we have divided it into a two part. This is our visible layer, that is input layer, and this is our hidden layers. And we say that in hidden layer nodes are not interconnected, in visible layers nodes are not interconnected. But this node is connected with all the neurons, this particular node is connected with all the neurons, and this input node is connected with all the neurons. So let us rotate it so that we can get understanding about it more clearly. So we have rotated it, let us align it. So now something it will look like this, which is more apprehendable to us as far as we have studied the deep learning. So now we have one visible layers and these are our hidden layers. For the sake of understanding, these are our features that decides what are the correlation or what are type of a relation exists between this data. So before moving ahead, we have to understand how the Boltzmann machine learns, because you don't have an output. If you don't have an output, you cannot compute a proper loss the way we have studied. So it starts with your input, and we have understanding that it has some kind of a weights that are multiplied with this input. Then this neuron is used to get some kind of an output, some kind of a calculation or something. So let us try to understand that this will multiply weight with each and every input. And then again it will regenerate that inputs. And then it compares whether this regenerated inputs are same as these inputs.
In the first case, it is not going to be same.
Because if you have input as 1, 2 and 3 and your weight is 5, 6 and 7, it is going to increase the value. So they are not going to be same. Again, it will pass through the neuron, regenerate the inputs, and mostly this process continues when this regenerated inputs are aligned with your inputs. Till that this process goes on. So once your regenerated inputs are aligned, you can always come back to your inputs because they are regenerated from this particular inputs using some kind of a weight and activation functions. So let us look into now with some numbers. So normally it starts with this. You have an input 1, it is multiplied by some weight over this neuron. You have some bias attached with these hidden values. Recall your regression section. You have an equation equal to y equal to ax plus b, where b is specifies for a bias. So this bias is used to get the balance. You apply some kind of an activation function, maybe sigmoid, maybe logarithmic function, and you get your new value. This shows your one step. But now this neuron is, or this particular feature is connected with all the inputs. So all these three inputs will be over here. Then you apply bias, activation function and value. It will look something like this. So you will multiply your input with weight 1, input 2 with weight 2, input 3 with weight 3. Initially these weights are randomly initialized, and then you have some biased, some kind of an activation function, and it will generate your value 1. This will same concept will apply for this particular neuron, this neuron and this neuron. So your diagram will look something like this. So now we have removed sigmoid is just for understanding. It is not compulsory to apply a sigmoid. It may depend upon the cases, but most of time it will do, or you can use a logarithmic function. So this is how it will look. So you have generated, these are your regenerated inputs, and this is your original inputs. And then you will back propagate, not a back propagate, but you will now move to a back pass. And now you will try to pass these values from this particular neuron to input using this particular weight. So your values will be multiplied by weight and a bias will be added. Something like this. And then you compare whether they are same. That means your Boltzmann machine has achieved the state, low level state, that you low energy state that you want it to achieve, else you have to continue the process. So now one word that is very common is a contrastive divergence. So what I am explaining over there, so this is what a contrastive divergence. So this is first part, and this is not only a 3-step process. It may take 10, 20, 100 steps to get this both inputs to be the same. So a simple concept, you start with an input, you regenerate the inputs, then you compare both. If they are not same or not close to each other, again regenerate, again compare, and you go on doing this process till you get the correct regenerated inputs. And these steps what we are doing is known as a
contrastive divergence.
And it is the part that allows your algorithm to learn. Not going more into detail, your weights can be used as a curve that can be plotted on a graph, and from that graph you can find within this 2 to 3 steps what kind of an adjustment is required. And that is what is an Hinton shortcut. You don't have to go till
n steps to get the answer. You may get it in 1 or 2 steps only. So now we have understood Boltzmann machines and its concepts.
I will strongly suggest that you go through this particular PDF file to get a more clear understanding and some mathematical formulas that how things works. This paper is written by Geoffrey Hinton, one of the professor who has developed this Boltzmann machine back in 1980s. And what we have covered till now is an intuitive level where we have tried to avoid the all kind of mathematical equations. And this is a kind of an equation you will encounter when you read the paper.